Hey guys, it's Mrs. Mabelli, and this is the hint video for the chemistry atomic structure task cards. So there's a couple things that you really need to be able to do a good job on the atomic structure task cards. So the first thing that you need is you need the notes for atomic structure. So if you are in an odd period, your notes are going to be in week 10. If you're in an even period, they're in week 9. Same notes, we just did them at different times. So just get the notes for atomic structure, and you're going to use several pages. You're going to use these top 2 pages for some of the task cards, then these 2 pages for some different task cards, and the last page for the last 3. These task cards are kind of broken into sections, and I'll go over that here in just a second. You're also going to need the periodic table. And if you look at your task cards and you click on this link right here, it's going to take you to the star periodic table. So those are the things that you're going to need. So your notes, periodic table, you're also going to need a calculator. So you can use your calculator that you've downloaded for your math class, or you can just Google up a simple calculator, whichever you prefer. Okay, so let's get started. Like I said, these task cards are kind of broken into sections. So task card 1, 2, and 3 are all about the different particles, the 3 particles, the structure, where they're located, things like that. So to do those first 3 task cards, you're going to use page 1 and page 2 of your notes. Okay? So page 1 and page 2. Mainly page 2 with the table, but you will need page 1 for some stuff like pi and things like that. Okay, so let's look at each of these task cards. Some of the task cards I'm going to give you quite a few hints, and some I'm just going to tell you where to find the answers on your notes. So task card 1 is all about what is true or accurate about protons, electrons, and neutrons. So it's going to ask you about the 3 particles. It's going to ask you about pi. All of that is located on the first 2 pages. So if you want to know about the particles, then you can look at the table, or you can look at your first page. Pi is about, that information is about halfway down on your first page. Okay, so that is task card 1. And if you would like to pause, well, really quick, let me talk about if you don't finish these by the end of class. If you don't finish these by the end of class, you need to click next at the bottom of every task card until you get to the end where it says submit. Then you can submit it. It will save your work. However, do not turn it in on Google Classroom at this time. You're only clicking submit on the form. Then later, when you are ready to complete it, you can click on the form again and go to edit my response. And after you have finished, you'll click submit again at the very end when you're totally complete, and then you will turn it in on Google Classroom. So it will save your work. So don't do a lot of work and then lose it, because a lot of you are not going to finish during class. Okay, so make sure you use the submit. So just click next until you see the submit button, and then submit. Okay, so now after you finish task card, if you're ready to work on task card 1, go ahead and pause, and then we'll move on to task card 2. Okay, so I'm going to assume you finished task card 1. Task card 2 is very similar to task card 1. It has a different model. So remember, there's a lot of different ways to make models of atoms. So we have a lot of different models on here. But it has the same similar style of questions, like what is true about protons, electrons, neutrons, things like that. And then you have down here on number 4 where it kind of changes up a little bit, and it starts asking what particle or particles make up the mass of the atom? Well, if you look at your notes, there are two particles that are big and one that is tiny. The two that are big make up the mass. The tiny one does not contribute. So figure out from your notes which two are considered big particles. And then it asks, where's all the mass located inside the atom? Well, think about where those particles are. Where those particles are will tell you where the mass is located. So then after you figure out, is the mass in the cloud? Is it in the nucleus? Is it in both? I'll give you a hint. It's not in both. It's in one or the other. So figure out which particles make up the mass, and then figure out where those particles are located. So I'm going to go ahead and tell you to pause now and finish task card 2. Okay, task card 3. So this is another different type of model of atoms. And it has similar questions. Which of these questions are kind of like putting together the information that you kind of knew from the first 2 task cards. So like describing the atom. Well, you can describe the atom by remembering where the particles are located and what kind of charge they have. Okay, so it talks about which one describes the atom. You need to know like which one is moving or orbiting, which ones are not moving, where they're located, things like that. All of that information is on page 2 of your notes. And then you have a couple questions about, let's see, what charge does the nucleus have? So that's question number 4. Well, if you think about it, the particles inside the nucleus, there's 2 particles in the nucleus, and one has a charge and the other one doesn't. So wouldn't the nucleus have the charge of the particle that is there located inside of it that does have a charge? Right? Remember, the particle that doesn't have a charge doesn't contribute. So, like, it should have the charge of the particle that is charged that is located there. And we have number 5. What charge does the electron cloud have? Well, think about the electron particles that are located there. What kind of charge do they have? That is on your notes, okay? So what kind of charge do the electrons have? The cloud should have that same similar charge. For number 6, I'm going to kind of just give you the answer because we didn't really talk about that much. So remember that the charges are electrical charges, so kind of like a battery. So for an atom to be electrically neutral, that means that the charged particles, the negatives and the positives, have to be equal. So think about that. The negatives and the positives have to be equal. Okay, so the positive particle is the what? The negative particle is the what? They have to be equal. Okay, so I'm going to tell you guys to pause and go ahead and finish task card 3, and then we're going to move on to task card 4. Okay, so task card 4. So far, the first 3 task cards, we basically were just using the first 2 pages of notes. Now, on the next 4 task cards, we're going to be using page 4 and page 5. So mainly the ape man stuff and the periodic table as well. Okay, so let's look at task card 4. Task card 4 is all about potassium. So it's really only about one element. So for this one, you don't actually need the periodic table because I gave you the box. Okay, so the number at the top of the box represents what? Well, you can look at your notes, and it has the box labeled and tells you which number is what. Or you can look at the periodic table, which also has the box labeled and tells you which number is what. you're really just answering the labeling. So it's really just directing you to notice that you can look at the labels. So which number is at the top? Which number is at the bottom? Now, what does ape stand for? What does man stand for? This is in your notes. So ape, what does that stand for? Man, what does that stand for? Notice that it says equals equals, it says minus equals, so it even tells you what you need to be doing. And then it says this one is just using what you know to find the specific numbers for potassium, for K. So the atomic number, which number is at the top or the bottom? The mass number, you've got a round on that one. Then you start using ape. Okay, remember that ape says that the atomic number or the top number is equal to protons and equal to electrons. So they're all the same. Okay, atomic number, protons, electrons. Okay, so then to find neutrons, you have to take the mass, the bigger number, subtract the smaller number, and get neutrons. Or take the bottom number, subtract the top number, and that's how you get neutrons. Okay, so then the last question is the only one that I felt like really should trick you a little, and that's the valence of potassium. Well, if you look up here, I gave you a model, okay? Remember, the valence is the electrons in the last shell. So the last shell of potassium is this shell, and how many electrons does that shell have? So it's the 1, 2, 3, fourth shell, and how many electrons are in the fourth shell? Okay, so I think you should pause now and go ahead and complete task card 4. Okay, task card 5. So task card 5 is all about using ape man with different elements. So task card 4 was using ape man, but it was all with potassium. This task card is going to make you use it with a bunch of different elements. So you are going to have the periodic table. Okay, so this first question is which one correctly describes the atom of the element sodium? So the first thing you have to do is you have to come to your periodic table. You have to find sodium, which is over here on the left. And you have to use ape man and figure out the protons, electrons, and neutrons. Well, remember, the top number is protons and electrons. Then to find neutrons, I round the bottom number, subtract the top number, and that gives me neutrons. Okay, so now that I know the 3 different particles, I can kind of describe sodium. Okay, I just need to know the numbers and where the particles are located, right? So like if you know it's 11 electrons or 23 electrons, I'm not going to give you the answer. You have to figure that out. When you know how many electrons it is, you have to know where the electrons are, basically. Okay? Then question number 2 is what is the total protons, electrons, and neutrons of phosphorus? So I have to find phosphorus, okay? And I have to find the protons, electrons, and neutrons. And just like in math, total means add them up. So I'm going to add all 3 of the particles together, and that's going to give me my answer. The next question is, what is the difference in the number of electrons between an atom of indium and an atom of scandium? So I have to find indium, and I have to find scandium. And then I have to find their particles. It said electrons, so I have to find the difference in the number of electrons. So I have to know what is the electrons of indium, what is the electrons of scandium. It says difference, just like in math. That means subtract. I'm going to subtract them, and that's going to give me my answer. The last question says an atom of an element has 48 protons, 48 electrons, and a mass of 112. What are the neutrons? Well, this is just using ape man. So A equals P equals E. I have the P and the E, so I have the A. Then I just take the mass, subtract the A, and I get the neutrons. Okay? All right, so I think you should pause and complete task card 5, and then unpause when you're ready to do task card 6. Okay, guys, so task card 6 is exactly like task card 5. It just uses different elements. So if you get confused, go back and watch what I said to do for each of the questions on task card 5, because it's the exact same thing. For task card 6, it just has different elements. Okay, so the only thing that's going to be hard on this task card is finding the elements. Okay, so go ahead and pause and then complete task card 6 and unpause when you're ready to do 7. Okay, task card 7. Task card 7 is a lot like the other task cards 5 and 6. You're going to be using your periodic table. You're going to use 8-man. You're going to answer questions. The difference is these are the questions of can you apply what you have learned. So some of these questions are super easy. Some of these questions are not super easy. Okay, so the main thing I would tell you is about question number 3. Keep in mind, what is the charge of the nucleus? What are the particles that are located inside the nucleus? And what are their charges? Okay, so when you think about that, if you know what's located inside the nucleus and you know their charges, then you should be able to tell me the charge of the nucleus. Okay. This is just finding protons, neutrons, and electrons. These are really just looking at the periodic table. Okay. Okay, so go ahead and pause and complete task card 7 and unpause when you're ready to move on to task card 8. Okay, so these are the task cards 8, 9, and 10 that are talking about valence. So you're mainly going to be using this last page of our notes. And these are the ones that you're probably going to have the most trouble with because we didn't spend a whole lot of time on valence. So, but they're actually the easiest. So once you get the hang of it, I think it'll be really easy. So the subatomic particle that always determines the element's identity. Well, look at your notes. Which particle determines the identity? Okay. Now, what is the acronym for protons identify the element? You should know that. That's in your notes. What atom is represented by image A? So I can look at image A. Now, I know if I count the protons, I can figure out what element it is. But I'm not 100% sure which are the protons, the red or the yellow. I also can't see for sure how many are there. But I do know that electrons and protons are equal. So if I count the electrons, then I should know the protons, and then I can figure it out. Okay? So that is how you do the next several questions. So A, B, and C, you're going to be counting the electrons because the electrons are the same number as the protons. That's going to give you the number of the protons. The protons identify the element. So then you can use that proton number to find them on the periodic table. Okay, then it says which part of the atom determines one, identity, and which 2, reactivity. Okay, so 1, identity, you should know that. That's just protons identify the element, right? And then we have reactivity. If you look in your notes on that last page, it talks about valence determining reactivity and chemical behavior. Okay, so that should be easy to do. So pause, finish task card 8, and then unpause when you're ready to do task card 9. Okay, so task card 9. So which subatomic particle of an atom determines the reactivity? Well, this is on your last page of your notes. What does valence determine? Reactivity and chemical properties. Okay. What number on the periodic table represents the valence electrons? This is also in your notes. Okay, equal to what number? It should be filled out right there. Okay. Okay, now, what is the valence of the atom represented in A? So we look at A. Remember, to find the valence, all I have to do is count the electrons in the last shell only. So I'm not going to count these because this is not the last shell. I'm going to count only these because this is the last shell. Okay, so you should be able to find the valence. Now, if you look at your notes, it says the valence is equal to this number, right? So, and it shows you how to find the group number, right? Because it says what group is atom A in. Well, if atom A has 1 valence, which is what it has, so 1 electron, then it's in group 1 or 1A. You're going to do the same thing for B and C. Then it says when trying to identify an unknown element, you can test how an element reacts. That sounds like reactivity with other elements. What does reactivity tell you? Well, what does valence control? Reactivity and chemical properties. So if you know the reactivity, what do you know? Okay, go ahead and pause and finish task card 9. Okay, let's do task card 10. So which of the following is the best conclusion about chemical reactivity? So we have this table here, and it talks to us about different elements, and it tells us the protons, neutrons, electrons, and it also says the outer shell electrons. That's valence. Outer shell, valence. So remember, valence tells us the chemical reactivity and the chemical properties. That means anything to do with chemical reactivity has to be about valence. If it's not about valence, then it's not about chemical reactivity. It's not about the chemical properties. So it says, what is the best conclusion about chemical reactivity? Which one of these is talking about the outer shell electrons or the valence electrons? This one says argon is stable, it is not very reactive. Which statement relates best to argon's reactivity? Another one. So it's talking about reactivity, so it needs to be telling us something about valence or outer shell electrons. Okay, this one just tells you to figure out which atom this is. Well, you really don't even need valence and neutrons for this because what identifies the element, right? So you can find that pretty easy. All right, this describes aluminum. So that's pretty easy. All right, at that point, guys, you should be done. You can pause or rewind and go back to other task cards if you need any additional help. As long as you were using your notes and watching the video, these should have been pretty easy task cards. So have a great day, guys. And make sure that when you complete this, that you turn it in, you click submit, and you turn it in on Google Classroom.